So, good morning, all of you. Welcome to Tech Alpha Anju. Today, we are going to learn something new like machine learning. So, today I'm going to explain about supervised learning and linear regression, logistic regression, and support vector machine. So, I hope you will understand what I'm saying. So, you'll also practice with me. Let's see one by one. First, we'll discuss what is supervised learning and what is linear regression, what is logistic regression, and what is support vector machine. And in coming videos, I briefly explain what is linear regression, what is logistic regression, and what is support vector machine. And now we'll start with supervised learning. So, supervised learning, it is a machine learning technique where the model learns from the labeled data, means input plus correct output. So, supervised learning is a type of machine learning that has the model learns from the labeled data, and labeled data means that the model having both input and also correct output are available during the training time. So the model knows what the output and it knows what is the input also. It means label data. Already we are giving the label. So it is available in the during training time. So the main goal of this supervised learning is, the goal is to learn the relationship between the input and also outputs, so that the model can make the predictions on the new data. So it is simple, right? So it will just learn the relationship between the input and output variables, so that it can be predict on the new data. So, coming to examples, we can take many examples like a house price predictions, map email detection, and disease predictions. So here, for example, input I am taking house size. So according to house size only now we can predict the house price. So if the house, if we have 1 BHK means we can predict like 8 to 10k. If 2 BHK means 10 to 15k, and 3 BHK means 20 to 25k. Like that we can predict now. So the model learns house size affects the price. So it is the example for the supervised learning. So, in supervised learning, there are two types. What are the two types? The first type is regression and second type is classification. What is the regression means? It is a continuous numerical values. It predicts the continuous numerical values. So, what is the continuous numerical value? Like it is increasing day by day, and the values which is in numerical format. So, what is the numerical where the numerical layer which is increasing day by day? And what is classification? Classification which predicts the category values. So if we student pass an exam, fail or not we don't know, but we can predict maybe he can fail or he can pass, but he can do one thing now. So classification is we can classify the variables. So we will briefly discuss on it. So now we are going to learn what is linear regression. Linear regression is one of the major topic in the machine learning. So where we are using in many places. So it has some mathematically simplified equations also. So what is linear regression? Linear regression is a supervised learning algorithm used to predict continuous numerical values. So what is linear regression means? It is a supervised learning algorithm. It is used to regression problems. It is used for regression problem. We already know that what is regression. Regression means to predicting continuous values, means it will growing day by day and also in numerical format. So where the output is continuous numerical values. So, for example, we can take a predicting house prices and predicting salaries and sales forecast. So, formula will see like it will come like y is equal to mx plus c. What is y is equal to mx plus c? So, where y is the predicted value. So, we already know that the program has both the input and output data. So, we are giving predicted values. We don't know actual value, just we are giving predicted values. Means y is equal to predicted values. X is equal to input futures, M is equal to slope, C is equal to intercept. X is input futures we are giving, M is equal to slope, where linear regression which follows the linear equation means straight line. So it will come like slope and interception. We all know that it is in the X and Y intersection. So we'll briefly talk about that. And if you see, for example, if your house size increases, the house prices is generally increases. Linear regression learns this in relationship and also predict the prices for new houses. So it will learn this relationship and it predicts the prices for new houses, because it knows if house size is increased means the prices will generally increases. By learning this, it will predict on new data, means new houses. So for example, we can predict house prices, salary, sales revenue, temperature. So this is all about linear regression. And once again, we will see what is linear regression. So linear regression is a supervised learning algorithm. It is used to understanding the regression problems where the output is continuous numerical value. For example, we can see predicted house prices and predicting salaries and sales forecasting. It finds the best fit straight line between input and output data. So the equation is come like y is equal to mx plus c. So where y is equal to predicted value, x is equal to input futures, m is equal to slope, and c is equal to interceptor. So we also seen one example like house size increase means prices also increases. Like that we can find out the relationship between the predictor values for the new data. So this is all about linear regression. Now we are going to see some Python program on it. Python programs comes like we are importing linear regression from sklearn.linear model. We are importing linear regression, and the model we are importing linear regression model here in program. So we are fitting, we are giving data to x train and y train, and we are training the model. We are training the model by using the linear regression, that is X tester. We are giving 20% of testing data to the X tester and another 80% of data to the X train and Y train. So I hope you understand what is linear regression. And now we'll go for what is logistic regression. So the definition for logistic regression is supervised learning. It is also a supervised learning algorithm for classification problems. So we'll see what is classification problems. So instead of, for example, instead of predicting numbers, it predicts categories, such as there in regression we are predicting the numbers, right? So we are predicting numerical numbers. But in classification, we are, instead of predicting numbers, we are predicting numbers. Sorry, instead of predicting numbers, we are predicting such as categories, such as yes or no, pass or fail, snap or not snap, spam or not spam. So it uses the sigmoid function. Okay, it uses it is a classification problem. Then why we are using the why we are using this regression? It is a numerical format. Now why we are using regression means it uses sigmoid function. It uses sigmoid function to convert the prediction values into the probability. Probability where the probability is known between the 0 to 1, 0 and 1. So it uses sigmoid function to convert predictions into probability between 0 and 1. So for example, we can take a disease prediction, whether the person has disease or not, and email swap prediction, whether the email is fake or not, and student pass or fail. Student pass or fail, we don't know. So like this we'll do classification. If the probability is greater than 0.5, means I told you na, the probability will come like 0 to 1, 0 and 1. If the probability is 0.5, the model predicts 1 class, means here we can see the model predicts 1 class. If the probability is like 0.5, the model predicts the 1. If high, 0.5, greater than 0.5 also, it predicts the 1. If the model predicts 0 or 0 between 0 and 0.5, it predicts the no, means it will worst case. Greater than 0.5 is good fit. Yeah. Then we will see formula like this, uses the sigmoid function. This is the sigmoid function, and the output ranges comes like 0 and 1. It will come like a 0.1, 0.2, 0.3, 0.4, 0.5. Up to 0 to 0.5, it is worst case. And from 0.5 is also pass, it is good case. And 0.5 to 1, it is good case. 0.5 to 1, it is good case. So this is the Python example. We are importing logistic regression from sklearn.linear model, and we are importing logistic regression in our program, and we are fitting the program, and we are predicting the text. Same, both linear and logistic regression are same, but the only difference is that is calculated by the numerical value, and this is per categorical value. So now we'll see something like support vector mission. And support vector mission is a supervised learning algorithm used for both classification and regression. So it is a supervised algorithm mainly used for classification. So it is mainly for use for classification. Support vectors are known as data points. So its goal is to find the best boundary. Here you can see examples. This is one class, this is another class, this is the hyperplane, which is boundary. It is classifying. If for example, these are the cats, these are the dogs, it is segregating. This is boundary, hyperplane means line, a straight line. So it is class A is cats, class B is dogs. Like that, it is giving one straight line between. So this is hyperplane, means best boundary that separates the different classes. So for example, we can use in a face recognition and image classification, text classification, snap detection. So here here the data points is then data points is closest to the boundary are called as support vectors. Data points which is closest to the boundary are called support vectors, and which often leads to better classification performance. It will lead to better classification performance. And the Python program is coming like from sklearn.svm. Import SVC. SVM. We are importing SVC from SVM. Model is equal to SVC. Model fit extra and y train, same as regression and classification problems, but somewhat different. Just it will separate the different classes by using the best boundary. Best boundary is also known as hyperplane. We'll discuss briefly this one. and this is all about supervised learning. And once again we'll see what is supervised learning and what is linear regression, what is this and all. So in briefly, here we'll do quick comparison table. So we'll take linear regression, logistic regression and super vector mission. So here linear regression is a regression type, logistic regression is a classification type, and support vector mission is a both classification and regression type. So in linear regression which predicts the continuous values, and also in logistic regression which predicts the category values, and also in support vector mission which predicts the classes and classes or values. So this is about quick comparison table. And in real time we can use real time regression, linear regression we use in house price prediction and sales forecasting and stock trend analysis. And logistic regression we use in snap detection and also disease prediction and customer churn prediction. And SVM we use in face recognition, handwriting recognition, fraud detection. This is the simple and easy explanation of what is supervised learning, linear regression, logistic regression and also support vector mission. Now we'll see one by one what is the interview questions. What is supervised learning means? Supervised learning is a machine learning technique where a model learns from the labeled data, where it has input and a correct output, so to make predictions on new data. Okay, and what are the types of supervised learning means? There are two types: regression and classification. Regression which predicts the predicted continuous values, and classification which predicts the category values. And the examples of supervised learning algorithms is linear regression, logistic regression, support vector mission and decision tree, and also random forest and k nearest neighbors. And the linear regression, it is something like supervised learning algorithm. It is used to predict continuous numerical values by finding the best fit line between input and output variables. And the equations of superlinear regression is like y is equal to mx plus v, mx plus c or mx plus b, whatever. Like y is equal to predictive values, x is equal to input futures, and also m is equal to slope, b is equal to interceptor. We'll discuss fully on it. And why do we use linear regression means to predict continuous values such as house price predictions and also house price predictions, salaries, sale revenue and temperature. Is the linear regression a regression or classification algorithm means? It is a regression algorithm because linear regression which uses the continuous and numerical values. So give a real world example of linear regression, predicting house prices based on the size, location and number of rooms. What is the difference between linear regression and logistic regression? Linear regression which predicts the numbers and it is a regression type, and for example is house price. Logistic regression which predicts the categories and is a classification type and it is a subdivision for an example. What are the exceptions of linear regression? Linear relationship between variables, independent observations, no multicollinearity and constant variance of errors, normally distributed errors. What is overfitting? When a model learns training data too well and performs poorly on new data. What is underfitting? When a model is too simple and cannot learn patterns from the data. So we use R square in linear regression. R square means how well the model explains the variation in the target variable. So it will explain what is the variation in the target variables. Means R square is equal to 1 means perfect prediction. R square is equal to 0 means no predictive power. So what is mean squared error? Mean squared error we use mainly in the regression problem, linear regression, and mean square MSC measures the average squared between the actual value and predicted values. It will find out the actual average squared difference between the actual and predicted values. Why do we split data into train and test? Means training set which is training the model, test set which is evaluating the performance on unseen data, right? So this is also important. And now why is 8 ratio of 20 train split commonly used? This is very important. In an interview they will ask why we are using 80 by 20 or what is the 80 ratio of 20, like that they will ask. 80% data is enough for learning patterns and 20% of data is sufficient for testing model performance. So these are the main interview questions. I hope you will understand. Now we will go for what is linear regression.